Hello. Today I am going to conclude the chapter electricity. Now, what is electric current? So, a stream of electrons moving through a conductor constitute an electric current. Yes, the movement of electron in a conductor. Conductor can be a wire of aluminum, of copper. So when an electron moves in a conductor, that constitute electric current. And conventionally, the direction of current is taken opposite to the direction of flow of electron. If the current flows opposite to the flow of direction of electron, if the electron is moving from left to right, the current will move from right to left. And the SI unit of current is ampere, very well. Yes, and we denote it by capital A, ampere. And how to set electrons in motion in a conductor. In an electric circuit. This is used. For this we use a cell or a battery. In order to set electrons in motion in an electric circuit, we use cell or a battery. A cell generates a potential difference across its terminals. It is measured in volt, V-O-L-T, volt, and the symbol is capital V. So the potential difference makes the electron move from one terminal of a conductor to the other terminal. Now, resistance is a property that resists the flow of electrons in a conductor. Conductors have different resistivity. Some allow electron to pass easily, some doesn't allow electron to pass easily. For example, suppose copper wire is the best conductor, aluminum, silver, so they are next best to copper. So the copper, aluminum and silver, they allow electron to pass easily because they do have very less resistance. In other words, tungsten and nichrome, they have very high resistance. Therefore, they doesn't allow current to move easily. So, resistance, control the magnitude of the current. Magnitude means the number, how many electrons will flow, isn't it here? So the current depends upon how many electrons flow in the conductor. Now the SI unit of resistance is ohm. The SI unit of resistance is ohm. Now the Ohm's law. This is very important. It often asked in examination. Ohm's law is very, very important. It is simple and very important. Ohm's law, the potential difference across the ends of a resistor is directly proportional to the current through it, provided its temperature remains the same. It means that the potential difference at the end of the resistor is directly proportional to the current passing through it. When more current will pass, then more PD will be developed. And the condition is that the temperature must remain constant. The temperature must not change. The resistance of a conductor changes with change in temperature directly. Means when the temperature will be more, the resistance will be more. So the Ohm's law okay, follows only when the temperature remains the same it is. Okay, so once again I am just telling you the Ohm's law. The potential difference across the ends of a conductor, okay, is directly proportional to the current through it, provided its temperature remains the same. Yes, its temperature must not change. This is the condition. Now, the resistance of conductor depends directly on its length. Yes. So, what are the factors on which the resistance of a conductor depend? So, the number one is on its length. If length is more, resistance is more. Second is the area of the cross section. When the area of the cross section is more, resistance is less. That means the resistance is inversely proportional to the cross section area of a conductor. Okay, means a thicker wire, mota wire. A thicker wire will have less resistance, and a thinner wire will have more resistance, because the cross area of thicker wire is more and the thinner wire is less. And the third thing is on which the resistance of a conductor depends is material of the conductor. Yes, of what the material is made up of, whether it is made up of copper, aluminum, silver, or tungsten, or nichrome. It's like this. It's okay. Now, the equivalent resistance of several resistors in series. Suppose several resistors are connected in series, R1, R2, R3, like this, in series, in one straight line series. So the equivalent resistance of such resistors in series is equal to the sum of their individual resistance. Okay, so R is equal to, means capital R is equal to, you can say, if R is the equivalent resistance, then R is equal to R1, R2, R3. Okay, so it will be like this. I'm just showing it. Just you can see it. R is equal to R1 plus R2 plus R3. It is here, or R4 like this, dot means you can connect more than 3 or more than 5. Okay, means you can connect it many. So the equivalent resistance will be R is equal to R1, R2, R3. It's like this. So okay, this is in series. Now in case of parallel, again resistors connected in parallel, the equivalent resistance is given by this 1 by R1 is equal to 1 by R. This is the equivalent resistance. This one is equal to 1 by R1 plus 1 by R2 plus 1 by R3. It is. You can connect it more than 3 also. Right? So this is the reciprocal. Right? Yes. So the total resistance is the it is like this. Okay, correct. So the total resistance in parallel is less. It is here less than the smallest resistor. One important thing that I am going to tell you about here, in parallel connection, the resistance in parallel have less resistance. Okay, very less resistance, even less than the least resistor. For example, suppose if R1 is 1, R1 is 2, R3 is 3 ohm, all ohm. So if they are connected in parallel, then the equivalent resistance will be less than 1 ohm, because 1 ohm, the resistor having 1 ohm is the smallest one. It is here. So in parallel connection, the resistance, total resistance is less than even the smallest resistor. So okay, जो छोटा रजिस्टर है 1 ओम का पैरेलल में, उससे भी छोटा रजिस्टर आएगा, पैरेलल में आएगा. So okay, पैरेलल कनेक्शन में. And now next, the electrical energy dissipated in a resistor is given by VIT, V into I into T. You know, V into I into T. What is V into I into T? Just I am showing you. Here you can just see that, okay, W is equal to VIT. What is W? W is the work done. It is same as the energy. You know, the work done and energy is the same. They are no different. They have the same unit, joule. So the electrical energy dissipated in a resistor is given by W is equal to VIT. Okay, W is the energy or the work done, I is the current, okay, V is the PD, and T is the time. Okay, this is the one way. The second way is that, just you can see here below that, okay, H is equal to I square RT. H is same as W. H is also the heat energy, it is. So it is I square RT. This is called Joule's law. Very important, it is Joule's law of heating. H is same as W. Here I have mentioned here W is equal to H. There is no difference in between these two here now. Work done or heat evolved. Dissipated means heat evolved or heat given out by a resistor. Means this is okay. So this is the formula of heat dissipated in a resistor. Now the unit of power is watt. The unit of power is watt, and 1 watt of power is consumed when 1 ampere of current flows in a potential difference of 1 volt. Means 1 watt is equal to 1 volt into 1 ampere. It's okay. 1 volt is equal to 1 volt into 1 ampere is equal to 1 watt. Right? And the commercial unit of electrical energy is kilowatt hour. Kilowatt hour, the commercial unit, and we call it 1 unit. This is the unit. Okay, we pay for our electrical consumption at our home. That is called the commercial unit of electric energy. It's okay. We do have also look at the meter. Just you can see here the meter is there now. So that is the meter, it is here. Okay. So that consumes energy in the form of kilowatt hour, right? So and that is equal to 1 unit. So 1 kilowatt hour, if you want to change it into joule, so that will be equal to 3.6 into 10 to the power 6 joule it is. Okay, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. If you want to convert this 1 kilowatt hour in joule, so that it is 3.6 into 10 to the power 6 joule. Okay, in next video I will make something else different it is. So okay, bye.